there are different ways in which data can be summarized or represented. In Chapter 2, we learned how data can be represented graphically. We considered how categorical variables or numerical variables can be represented using graphs that communicate the insights contained in the data. In this chapter, we move on to using numbers to summarize a bunch of data. On page 2 of your notes, we begin by talking about measures of central tendency. You see, when we talk about measures of central tendency, we're talking about what number can be used to represent a bunch of numbers, or, put another way, a number that is typical of the whole bunch of numbers. So, without any further ado, we want to answer the first question here. What kind of numbers or values should I use to describe the typical value of a categorical variable? To get us going, we remember that a categorical variable can have two levels of measurement. These can either be nominal or ordinal. What we recall is that for nominal categorical variables, the values only names or groups entities of interest. Examples of nominal categorical variables are eye color, nationality, place of origin, zip code. You observe that in each of these examples, the values you get do not have any inherent ordering structure. In contrast, we can talk about ordinal categorical variables. The ratings of Amazon products is an ordinal variable because a 5-star product is not in the same rank or group as a 1-star product. The responses to a survey, whether satisfactory, unsatisfactory, and otherwise, these are definitely examples of ordinal variables where there is an order structure inherent in the values. Pay scale, military rank, these are other examples of ordinal categorical variables. So, an ordinal categorical variable groups and at the same time ranks entities of interest. So now that we recall the two levels of measurement that can be ascribed to a categorical variable, namely nominal and ordinal variables, we want to move further to discuss them in further detail. You see, if the categorical variable only groups and does not rank the entities on which data was collected, what we do is we only report the mode. We will talk more about what the mode is in a little bit. All we need to want to do right now is to remember that such a categorical variable is called a nominal categorical variable. Otherwise, if the categorical variable both groups and ranks the entities on which the data was collected, then we must report the median. Again, we're going to discuss what the mode and the median are in a little bit. And whenever you have a categorical variable that both groups and ranks, such a categorical variable is called an ordinal categorical variable. In this chapter, we're going to learn about the three most commonly used measures of center, namely the mean, which you might have heard before, the median, possibly, you've heard about that too before, and the mode. Whenever we want to describe the typical values of a categorical variable, we only use one of either the median or the mode, depending on if the categorical variable is ordinal or nominal. So, time to talk about the median in detail and the mode in full detail. We'll also consider situations in which it is appropriate to report the median, and the mode as typical values of a categorical variable. To emphasize, whenever you have a categorical variable, you do not ever use the mean. We only use either the mode or the median as the typical value, and we will consider examples. So, what is the median? The median, in layman terms, is simply the median value in a set of data, but it does not necessarily have to be one of the observed values. We will see an example of why this can be so. In order to find the median, usually when you're given a bunch of data values, you must first order the data set from the smallest to the largest data value. Then, for the mode is the number, the mode is the number of value in the data set that occurs most frequently in the data set. With all that said, it is time to consider an example of a real-life situation where we would like to use either the mode or the median to report typical values of a categorical variable. In this example, we are told that multinational corporations face stiff competition in the carbonated drink category, also known as soda or pop, depending on where you live. Data were collected on the 2015 US market share of leading sellers of carbonated soft drinks, summarized in the following chart. And here is the chart. We see the different categories: Coca-Cola, PepsiCo, and so on. The question we would like to answer is this an appropriate data display for this data? Explain. Well, the answer here is yes. And that is because a pie chart is very good for graphing categorical variables where a whole collection of the US market share is broken down into groups. Just to emphasize, again, the pie chart is a very useful graph in this scenario because it is very useful for graphing categorical variables where you have the different categories whose whole collection of possible values have been broken into groups. So, circling back to this context, the next question we want to answer is, which company had the largest share? Obviously, we can tell that that is Coca-Cola. Besides recognizing which company had the largest share, the next question is, which measure of center did you use or would you use to describe what is the typical US market share or where it's coming from? Definitely, we would say that in this case, since this is a categorical variable and it's a nominal categorical variable, we will report the mode, that is the company that has the largest US market share of leading sellers of carbonated drinks. This is intuitively related to the mode, that is the one that occurs the most frequently. So here on your screen, we see that the measure of center to use for this nominal categorical variable is the mode, which is Coca-Cola. So, and that is because the data values are those of a nominal categorical variable. We proceed to the next example. In the next example, we are told that a kitchen appliance maker surveyed a sample of customers to determine whether they preferred black, white, or stainless steel appliances. The data were coded as follows: 1 for black, 2 for white, 3 for stainless. A sample of 17 responses from customers are given below. Here we have the data values. How would you graph or visualize this data? Immediately I look at this data, I can tell that this is values that represent a categorical variable. It will categorize those who prefer black from those who prefer white and from those who prefer the stainless steel appliances. So the next thing I ask myself is it nominal or is it ordinal? Well, is it as though those who prefer black are better than those who prefer stainless? No, there is no order here. That is not true. So this tells me that this is not ordinal categorical variable. Rather, this is nominal. For nominal, the appropriate measure of center to report is the mode. So in this case, I would choose to report the mode, and to graph it, I can either use a pie chart or a bar chart. To emphasize what was said, if you would like a breakdown of the whole collection of 17 responses, we can use a pie chart. Let's see that in StatCrunch. Here we are in StatCrunch. I'll go to Graph, go to Pie Chart, and I want with data. Click on that option, and I have recorded all of the data values under the column color code. So I'm going to grab the column, double click on it, and then I am going to, just for plain's sake, the color scheme I'm going to choose of choice will be mixed 11 colors, and click on compute. And you can see this is the pie chart, which shows that this shows that 1 and 2 both occur 7 times each and represent a percentage of about 41.18%. But then, besides a pie chart, we can also use a bar chart to visually represent the different response types ranked based on the frequency of occurrence. To do that, in StatCrunch, I'm going to close this and then go to Graph, Bar Plot with Data, click on that, then choose Color Code. I would usually like the value above the bar and then compute. And I can see again that there are different color codes here. So I see 1, 2, and 3, the different values. And this represents a distribution of values with 2 modes. So this is said to be a bimodal distribution. We will talk more about that. So back to our notes. Then we would next like to compute the mode and the median for this data, and we would be interested in answering the question, which of the median or mode should you report as the typical response of a customer? Explain why. From what we have done so far, in order to get the median, the first step is to sort the data set from the smallest to the largest. So I'm going to sort the data first, and I'll do that as follows. So now on your screen, you can see the sorted data values. Then, in order to get the median, we want the number in the middle. Well, if you count carefully, I have 17 responses. So if I were to take 8 values to the left and 8 values to the right, the number right in the middle is the number 2. This is the median. Then, for the mode, we need to find numbers that have the highest frequencies. From what we drew earlier in StatCrunch, we saw that the numbers 1 and 2 both occur 7 times each. In other words, in this case, there are 2 modes in this case. 2 numbers that both have the greatest amount of frequency of occurrence. So, again, we now recall which of the median or the mode should you report as the typical value here. The correct answer is the mode. And that is because even though these are recorded as number values, these numbers actually represent different categories of preferences of different customers. So this represents values of a nominal categorical variable. And so we should use the mode. So the reason why the mode is the best measure of central tendency to report here has been provided here on your screen. And again, to emphasize, it is that the data values that we're collecting data on here are values of a nominal categorical variable. We proceed to the next example on the next page. A dean is focused on one particular question on the course evaluation survey that was administered in every class each semester. The question was, considering all factors of importance to you, how would you rate this instructor? 1 is excellent, up or down to 5, which represents very poor. The dean then had the staff compute the means for each class and for each professor. He then listed classes and faculty in order based on the mean values, and he based a major part of the performance evaluation on where a faculty member stood with respect to the mean score on this one question. By the way, he carried the calculations for the mean to 3 decimal places. How is this a wrong way to carry out the analysis of the data collected from each class on each professor? Here's the first note. These data values represent categorical variables because an instructor that's rated excellent is not in the same group as an instructor who has been rated very poor. They're in different groups or categories. Then there is an ordering structure here, in which case you have excellent down to very poor. So this is an ordinal categorical variable. Now you recall that whenever we're dealing with an ordinal categorical variable, the values that should concern us should be the median, not the mode and not the mean. In fact, we never compute the mean for categorical variables. So this is important to note. So this is a very wrong way to carry out the analysis because the data values collected are those of an ordinal categorical variable. So the preferred measure of center or typical representative value should be the median, not the mean. Again, the mean of values of an ordinal variable has no real-life meaning with intuitive sense. Rather, it is based on unfounded assumptions. To cap, whenever we have an ordinal categorical variable, we should only report the median. So, in conclusion for this video, you should note that the mode can also be calculated for quantitative data or numerical data, and we shall see that in a little bit. Now, for example, if the data set is red, 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 green, green, yellow, purple, black, and blue, the mode is red because it occurs the most often. We want to recall that, and we also want to note that the mode can also be computed for numerical or quantitative data values.